Today's lesson is about derivative rules of exponential functions. If y equals e to the x power, then derivative of fx will be e to the x power. We can write down this way. If y equals b to the x power, then dy by dx equals b to the x power times the natural log of b greater than 0. Now I will show you why for b to the x power, the derivative of that equals b to the x power times the natural log of b. We know the inverse rule, this. So for b to the x power, I can write down e to the natural log of b to the x power. We can drop this x down. You will get the e to the x times natural log of b. Therefore, derivative to b to the x power, you can write down e x times natural log of b. We do the derivative. E to the x power derivative will be itself. Therefore, I can get this itself. Then use the chain rule. You have to do the derivative to this exponent. Therefore, you need to multiply by natural log of b. We know for this, that's equals to b to the x power. So I can write down b to the x power times the natural log of b. Let's go to guided practice 1. Find the gradient function for fx equals to these four functions. For a, e to the y minus 2x squared, derivative for that. Since e to the x power, derivative will be e to the x power. You will do e to the y minus 2x squared first, then use the chain rule, do the derivative of y minus 2x squared. It will be negative 4x. So the final answer will be negative 4x times e to the y minus 2x squared power. Now let's go to b. We have 20 y minus e negative 2x power. First of all, do the distributive property. You will get the 20 minus 20 times e to the negative 2x power. Therefore, for the derivative of this function, we got to do derivative of 20 minus 20 times e to the negative 2x power. This will be 0. Negative 20, that's a coefficient, times e to the negative 2x power first. Then use chain rule, do the derivative of negative 2x will be negative 2. So organize negative 20 times negative 2 will be 40 e to the negative 2x power. Now let's go to say x squared times e to the 3x power. First of all, we got to use this product rule. Because you have two functions multiply each other. So the derivative to the x squared times e to the 3x, then plus x squared times derivative of e to the 3x power. derivative of x squared will be 2x times e to the 3x plus x squared. E to the 3x derivative, first of all, we do the e to the 3x, then times. Derivative for this 3x will be 3, so we put this 3 over here. Then this will be the derivative for C. Now let's go to D. Derivative of e to the x power over square root of x. We know that this is a quotient of two functions. When you do the derivative for that, use this quotient rule. Therefore, we do square to the denominator. Then e to the x power, we do derivative times the square root of x. Then minus here. E to the x power times derivative of square root of x. For derivative of square root of x, we know that will be 1/2 1 over square root of x. Try to remember this easy derivative of square root of function. So we work this out. Derivative of e to the x power, that will be e to the x power times the square root of x minus e to the x power times 1/2 1 over square root of x. Square root of x squared will be x. This is a complex fraction. We have denominator is 2 times the square root of x. Therefore, top and bottom, we need to multiply by 2 square root of x. 2 square root of x. Then we do distributive property. You will get the 2e to the x power times x. I will put the 2x here. Minus e to the x power over 2x square root of x. Leave as it is. Now let's go to guided practice 2. Given f(x) equals e to the kx plus x and the derivative of f of 0 equals -8, find the k. First of all, we will work out the derivative of f(x) equals e to the kx power. Then do the derivative of this exponent will be k. Then plus 1. Then I need to plug 0 to this derivative function. You will get e to the k times 0 times k. Then plus 1. That is e to the 0 power is 1. So k plus 1, it will be equals to -8. Therefore, k equals -9.